Welcome to the session Magnetic Lines of Force. The aim of this experiment is to draw the magnetic lines of forces in the combined magnetic field of the given bar magnet and Earth's magnetic field and to locate null points. We can determine the pole strength of the given bar magnet after that. The apparatus required for this experiment: drawing board, drawing paper, magnetic compass needle, a bar magnet. Procedure to draw the magnetic lines of forces in the combined magnetic field of the bar magnet and Earth's magnetic field when north pole of the bar magnet pointing towards north pole of geographical direction. Now, consider the wooden board. Place it on the table. Consider the drawing paper and place it on the wooden board. You can fix it with the help of the drawing pins provided. Now, place the magnetic compass at one of the corners of the table. Now, we have to adjust the table according to the direction of magnetic meridian, that is north-south of the earth. Now we can represent geographical north-south directions. Take a pencil and mark the north and south, east and west. Remove the point. Join the points corresponding to the directions, geographical directions. Now mark north, south, east and west. Draw a line at the middle of the drawing paper parallel to the geographical north-south directions. Place the given bar magnet on the drawing paper with its north pole pointing geographical north. For our convenience, take the trace of the given magnet with the help of the pencil. Now, take the magnetic compass needle, place it on the paper at north pole of the bar magnet. The one end of the magnetic needle which faces south here is now taken as one dot, and the arrow mark which is pointed here will be followed by considering respective points. We have to follow the arrow mark which shows the points corresponding to magnetic lines of force in the combined magnetic field. We can construct a magnetic line by joining all the points. Now, take one more point nearer to the magnet north. Now, keep the magnetic needle at the second one and take the first point. After marking the first point, follow it as we said earlier, such that the south pole coincides with the first mark. Now take the second mark. Similarly, we have to take all the marks till the magnetic needle reaches the south pole of the bar magnet. And we have to join all the points to construct the magnetic line of force. In this way, we have to place the magnetic needle on the other side of the bar magnet at the north pole, and we have to take similar marks on the second side. After joining all the pencil markings, we can show the magnetic lines of forces. Now, we have to keep arrow marks on these lines in such a way that the lines will come out from the north pole and enter into the south pole of the bar magnet. Now, we have to find the position of null point. Null point is that in the combined magnetic field where the resultant magnetic field will be 0. When the north pole of the bar magnet is pointing geographical north, the null point will be obtained on the equatorial line of the bar magnet. In this experiment, when we are going to move the magnetic dipole slowly from the center of the bar magnet along the equatorial line, at one point 0 deflection will be observed. That point corresponding to the 0 deflection is said to be null point, where the resultant magnetic field will become 0. These type of null points you can observe on both sides of the bar magnet. When we place the magnetic compass needle on the other side of the bar magnet, and if you move this gently on the equatorial line, at one point the 0 deflection is observed. That is the point which is said to be null point on the other side. After plotting all the lines of forces and after representing the null points, we have to find the distance of separation between the two null points. Here, by using a scale, we can measure the distance. Here, in our experiment, the distance is 31.4 centimeters. Now, the magnetic length will be identified with the geometric length. The geometric length of the given bar magnet here is 7.5 centimeters. To draw the magnetic lines of forces in the combined magnetic field of the given bar magnet and the Earth's magnetic field when the bar magnet south pole is facing the geographical north. First, keep the drawing paper on the board. Now, the magnetic compass is placed at one of the corners and recognize the north and south of Earth. After considering the geographical directions, consider scale, draw a line parallel to the geographical magnetic meridian and keep the given bar magnet on this line. Trace the bar magnet by using the pencil. And now, the north pole of the bar magnet and take a point on the drawing board where the needle deflects. We have to follow the needle to represent the successive points to draw the magnetic lines of forces. After considering all the points on both the sides of the bar magnet, we get the magnetic lines of forces as shown. Null points corresponding to the bar magnet south pole when faces the geographical north. We know that the null point is that in which the resultant magnetic field is 0. In this condition, when the south pole of the bar magnet faces the geographical north, we get null points on the axial line of the bar magnet. Consider the magnetic dipole compass needle and move it slowly on the axial line, and at one point you can observe the 0 deflection. Consider the other side of the bar magnet and again move the magnetic compass needle to obtain the null point. We conclude the experiment after recalculating the magnetic moment and magnetic pole strength of the given bar magnet.